We are starting soon. I am just allowing people to connect. Welcome to this session on how to manage cyber risk related to artificial intelligence solutions. I am super excited to be once again sharing tools and practices and some reference materials in this wonderful event, the Stronger 2023, organized by CyberSaint. And my name is Hernan. I am a professor in risk, compliance, and cybersecurity. And I am developing and working on software and algorithms using artificial intelligence, particularly when it comes to computer vision. We are seeing that this year everybody is going bananas with artificial intelligence. There are so many executives from many different functions, from compliance, from legal, from procurement, from development, from IT operations in general, talking that we need to improve the way that we are assessing risks and new requirements and new threat vectors that they are coming from artificial intelligence solutions. And one of the main scenarios that we are always identifying is shadow artificial intelligence. In a similar way that shadow IT is posing a very high exposure to the risk. If we are unable to detect and have an inventory of solutions that they have some algorithm based on machine learning or many of the different technologies that we call artificial intelligence, we are never able to do a risk assessment or to implement controls or to uh, identify who is owning what. So shadow IT is a new risk scenario that is coming this year into this area that many companies were struggling to identify the assets, the solutions that they are using artificial intelligence. It looks quite easy, but in practice it's not. Some organizations were looking at the contracts, trying to extract some terminology related to artificial intelligence. Some others were using different scanning tools. However, if we are unable to tell what solution is using an algorithm to predict, to decide, is super hard to really understand what is the posture in terms of compliance, in terms of the controls. Another topic related to artificial intelligence is how we are assessing the impact on the users and the society in general. When it comes to responsible technology, when it comes to privacy, when it comes to regulations related to essential service providers, assessing the impact on our end users is becoming critical. We have methodologies that are able to assess and quantify the impact for the organization. For instance, um, how much we need to invest if we need to regenerate data because it's lost. And we were missing what would be the impact of those scenarios on the users, on the people that are being monitored, on the general society. So when it comes to biases and misuse of artificial intelligence algorithms, now we need to add a new type of impact assessment on the outside, the stakeholders of the organizations. Another scenario that is hitting this area is data poisoning. How data can be manipulated in order to change the predictions, how the algorithms can be confused in order to provide an output that will have some incentive for somebody, particularly an adversary, affecting the operations. Another scenario that is coming in for the artificial intelligence-based software is hacking. But hacking in terms of stealing the training data, stealing the feeding data of the model. This is something that is becoming critical, and many of us dealing with artificial intelligence risk were covering how it's possible and how hackers are able to finally get in some prompts and some techniques in order to retrieve data that it was used for training the algorithm. We are learning and the hackers are learning. So now this different scenario is a good the discussion point when it comes to our stakeholders. And finally, deep fake. Um, Many solutions that they were using face recognition for identify users are no longer valid. Deepfake is affecting traditional scenarios that we were covering in risk, for instance, CEO impersonation, how um, adversaries can now manipulate voice, they can clone even a complete video conference real time for an executive, for the CEO, in order to, from approving a payment, approving changing vendor accounts, or even manipulating some commitments and advertising on behalf of the company in order to finally commit a fraud. There are new techniques when it comes to artificial intelligence algorithms that are making very difficult to differentiate when we are seeing a fabricated identity, because the voice is cloned, the expressions are cloned, of course, face is cloned. So now we are much more exposed to these type of events. And this session is about the autopilot, because we can use the same technology in order to identify very early when we are being attacked. And we can analyze data as we never had these functionalities before to understand correlations for new scenarios. We can now improve models. We can now predict what is going to happen in a more accurate way that we had before our models in risk. We are able to detect fraud. Fraud is a very easy scenario to train the algorithm, because we know when very immediately when there is actually a fraud that is occurring. For instance, somebody is misusing a credit card, and when it's not. So explaining an artificial intelligence algorithm in order to do machine learning and to understand correlations, what we want to accept as an usual behavior and what is an unusual behavior is way much powerful now. And we can also generate better insight for decision making in terms of predicting and using deep learning. I am very fascinated when it comes to risk management on how we can um, use these new functions, new packages that allows to query data and to analyze correlations that you can never identify as a human. And let me go to the to some technical approach here on the practical implications of artificial intelligence. There is a hell attention on how to quantify cyber risks because insurance companies are requiring this assessment, or we want to negotiate the premiums much better with a proper quantification because we have new requirements in order to show proactivity and accountabilities when it comes to implementing controls, to do security assessments, that we have this objective to be a data-driven company in terms of risk assessment long before, and now our models are evolving. So when it comes to cybersecurity, when it comes to assessing risk in software, there are basically three most useful distributions in order to foresee what is going to be the impact. The most common events and what actually we are using in most of the cases is log normal. We have a long tail of events, but we can also use Pareto when the losses are extremely large. For instance, data breach, ransomware attacks, they may have extreme scenarios that they are following a Pareto distribution in order to uh, foresee what is going to be the financial impact. And eventually, for some scenarios, we are detecting a log normal distribution, particularly when it comes to human errors. And we can use Python functions, we can use formula in order to model the risk and to foresee how for our organizations the impact will materialize. This is a study. This is the most comprehensive study on losses coming from cybersecurity incidents in the last, I think that this is 5 years. And when we look what is happening on the fields and we analyze many cases, we, we can detect that actually using log normal distributions is the type of losses that we are suffering in IT. So in most of the cases, when we are looking at losses in the past, when we are benchmarking data, for instance, in the banking industry, it's very common that we can have data coming from peers. Using log normal distribution seems to be the most common type of losses, in which we have, in this case, 8% of the losses that they can produce extreme fines, cost, compensations, loss of productivities here. On the other hand, we also need to model how often this event will occur. And in practice, we are using Poisson as the most common distribution, particularly on artificial intelligence scenarios that they are creating losses that they are occurring several times a year. On the other hand, also we can use Bernoulli or we can use triangular distributions and PERT. We can also model that on the Python formulas. And when it comes to risks that we are expecting to be materialized less often than a year, for instance, we are expecting to have a down time event in the e-profiling software because of the deterioration of the artificial intelligence training data once each 5 years, for instance. Then you can use Bernoulli, and sometimes you can use the worst of the best scenarios and start using a triangular, like best case, worst case, and um, the most common case. And I put in the slide the formulas that they can work together. Let me give you one example on how we are creating a script in Python, and I am super happy to share the full scripts if you contact me after the session. Let's say that we have a risk scenario that there will be 4 denial of services attacks a year, and we can assess that 67% of the losses, this is the loss normal distribution, this is the delta, will be between 80,000 to 120,000 US dollar per event. This is how much we can lose. And you can use Python in order to run the Monte Carlo simulations. These are 2 scripts that you can use, and you can see that this approach is simulating how many of these attacks will occur in 10 years. For instance, this year will be 2 attacks, next year will be 5, sorry, the year after 6, the year after not attack, not successful downtime. And then you can also use the a similar approach in order to simulate how much will be the loss, how sure you are. So you can randomly, depending on the data that you are using in your model, you can simulate how much will be the loss, and you can combine the number of events and the number of losses. And in a Monte Carlo simulation, we usually run more than 10,000 random scenarios. You can combine how much is going to be the losses and finally get the loss exceedance curve that is telling you year by year what are the chances to be exposed to this risk. And this is how you can tell, for instance, that if you want to cover 80% of the scenarios, you need to set apart almost $100,000 a year in order to be prepared for this type of attacks. But when it comes to cyber, we can divide the losses into our cybersecurity objectives in terms of the confidentiality, the integrity, and the availability. You can do this analysis by asset, by process, or by services. When we are assessing a scenario for confidentiality and integrity, we analyze how many records will be lost or corrupted by the cost of each record set. When we are talking about availability, we are considering downtime. We can say okay, in these artificial intelligence solutions, if the algorithm needs to be corrected, it's going to be a downtime between 1 to 2 hours, and that is going to be the cost. So you multiply different losses in terms of first the impact on IT, on the IT department. Then you can also consider losses in terms of compliance. We have the AI law in Europe. We have Chinese law on artificial intelligence. We can have a lot of requirements coming from our industry or contracts. So you can consider those losses as a second tier. So you're going to have to recover data, recover services, and you can have a dialogue with the IT owner. But also in terms of compliance, many of these scenarios are externally affecting the third parties, the stakeholders, the users, the society as a whole, and you're going to have to pay some compensations, fines, depending on the contracts. And finally, those scenarios that they are externally visible, creating a high loss, you're going to have clients changing. They are not going to use your service. They don't want to get this e-loan approval done. And you need to consider the loss in terms of the clients affecting their reputation and their revenue. And that is the type of cost that we need to assess with marketing. And this is how you can put everything together. In order to provide a good guide in this session, I divided the typical scenarios that we are covering for artificial intelligence solutions. In terms of the confidentiality, the main scenario is disclosure. It's an employee or consultant that may expose the model or the training data. There may be an intention because of that, maybe some subversion threat, somebody is paying your employee to get the artificial intelligence model because they want to explore what are you doing as an organization, or they are able to collect the data because there was a improper configuration on a server, and finally there is a disclosure. Another scenario that we are covering is the oracle, is that an external attacker may input data on the model to analyze the output. And it's a way that they can use reverse engineering to understand how the model is working, and they can steal the model by using this type of techniques as a threat vector. In terms of integrity, the typical scenario here is poisoning, is data poisoning. The attacker may manipulate the training data, may try to affect the outputs, they may introduce backdoors, and finally, being able to alter the model in a way that is producing an output that usually is related to a fraud scheme. We also have evasion, when the attacker may modify part of the training, maybe some little data sets that they are classified, and there are very few of them in a particular group, that is going to have an impact on the balance, may have a huge impact on the output. Particularly when they will start manipulating highlights or values that they are very high. Biases is also another threat. It's like the developer is using incomplete data for the training. The training is not representing the population that is expected to use the model. And finally, some discrimination output will occur. And in terms of the availability, we usually have the same type of scenarios like denial of services, perturbation, abuse of third parties. Abuse is also a threat vector in artificial intelligence that is increasingly discussed. We may have a model that is working and is working fine, but it can be easily misused by a crime organization, by fraudsters, uh, in order to do something that we were not considering as the use case for that solution. So understanding not only the users, but also the use of the models are becoming extremely critical in order to assess those scenarios. We have an ISO on artificial intelligence risks, and is covering security, safety, robustness, availability, data quality, maintainability, and expertise. I wanted you to have those targets for the solutions because this is where we start in order to facilitate the risk assessment on this type of solutions. What are our ambition, our target in terms of security or safety? Can we control the use? Can we prevent the misuse? How? What is the target here? And using these scenarios coming from ISO are very useful in practice in order to identify meaningful perimeters of the risk affecting the models. Also, I wanted to recommend objectives that they are discussed in the model and how to do impact assessment. I'm gonna be in the networking area for questions and also if you need to have more references. But one of the things that I have done is to improve the presentation with a tangible value for you. So I had written a scenario that you can use, a taxonomy that you can use for artificial intelligence risks, factors, and threats. I find this information super helpful in practice. I am, for instance, listing what will be for the compliance losses like fines or contractual compensations, and which kind of compliance obligations we are considering when it comes to artificial intelligence algorithms. I have also discussed different solutions and a scenario for the risk in terms of the target, like compliance, like effective solution, like how we can explain the transparency. So the risk is that we are unable to explain the backdoor outputs, the misuse, the unethical outcomes. Super important in practice when we are facilitating these type of exercises. And then I also wanted you to have a factor taxonomy that you can link the root cause of the risk that you are assessing, for instance, the complexity of the environment, the level of automatization. These are factors that they are increasing the risk, and the threat taxonomy, how it's working together, very easy to follow. So you got the vectors here, and you can use these results very nicely for working, and also a list of IT controls. What are the controls that I am recommending that you can enforce when it comes to artificial intelligence solutions? So I am very happy to share more tools here. We are a community here at the Stronger event, and you can connect with me on LinkedIn. You can email me or tag me on Twitter, X, in order to protect our organizations and being able to be good facilitators for developers, for people in procurement, people at the top level, when they need to understand what is the exposure to risk coming from using algorithm when it comes to artificial intelligence. Thank you for being here in this session, and best regard from Copenhagen.